Welcome to this video. It's the third one in this series about cracking the paper 2 Cambridge iGCSE Chemistry. And this question is about rates of reaction. So have a chance to look at this and pause the video if you wish to have a go. So it talks about two factors that can affect rates of reaction: temperature and concentration. And the question goes, which row describes the effect of increase in both concentration and temperature on collisions between reacting particles? So when we actually did this survey with year 11s, 50 year 11s, we actually found that answer C was the most popular answer and indeed the correct answer. But we also found that D is the biggest the biggest temptation for making a mistake. So around about 12% of candidates actually picked D. So let's just go through this and see why they did that, or why they may have done that. So increase in concentration has no effect whatsoever on energy, so we can eliminate that completely. Increase in temperature has to increase the number of collisions per second. It's a very key phrase, collisions per second. So you can see how important it is when you're actually talking about rates of reaction and the factors affecting the reaction rate. More collision and more collisions with sufficient energy to react. That's actually really, really useful as well. So those two are truths, and more collisions per second only is a truth as well, and more collisions is common in A and C, but then you've got the extra two factors from temperature, C and D. So the two answers are completely aligned in response C. Now, you can actually see that D is actually only different because it's got this extra line over here, sufficient energy to react. So don't think that this question is an answer where you can actually combine both factors together. Increase in concentration has no effect on the energy of the particles. It's only when you actually have an increase in temperature that you actually have an effect on the particles itself. I'm going to move on to question number 2 now. So this question is actually about energy differences in chemical reactions. We've got an endothermic and an exothermic reaction. It doesn't really matter what is actually combining. The displacement reaction is given here, and remember that displacement reactions involve the swapping over of two elements that could be differing in reactivity. The more reactive element will displace a less reactive element from a compound of that less reactive element. So we've already been given enough information to match up the facts, and this actually does it is important because this is mentioned in one of the answers. So you may be wondering why it is that there's mention of magnesium oxide and carbon, and that might actually put you off choosing 2 as a correct statement. But there's actually enough information in the question to actually say that, to actually get you to realize that magnesium oxide and carbon are actually the products. So the endothermic reaction energy profile can look like this. Now remember that you start off with reactants. As time goes by, looking at the energy, the energy within the actual chemical system that's actually reacting. You start off with reactants. Now it is taking in energy that's been transferred from the surroundings. So the system is going up in energy. The reactants become their products. Overall, you actually have cooling of the surroundings. The temperature goes down. So that's what happens with an endothermic reaction. So have a look at exothermic reaction now. So how is that different? I'll just write that over here. Let's have a look. So with an exothermic reaction, the energy in the system starts off very high. The processes take place and energy is transferred to the surroundings as time goes by. So as a result, the surroundings warm up because they start to store all of that energy that has been transferred from the chemical reaction that's taking place. So which statements about the two reactions are correct? Now, it starts off with the energy of the products formed in the neutralization reaction is greater than the energy of the reactants. Well, is that true? So let's have a look at the energy of the products formed in the neutralization reaction over here. The products is at a higher level than the reactants. So the products are at a higher level than the reactants. So that is a true statement. Let's have a look at number 2. The energy of magnesium and carbon dioxide is greater than the energy of magnesium oxide and carbon. So remember that magnesium and carbon dioxide are the reactants. The products are magnesium oxide and carbon. That's why it's quite crucial for us to understand what is actually going on with a displacement reaction. So we're not put off by that, that little turn of phrase. So you can actually see that the energy of the reactants, magnesium carbon, is greater. So that is a true statement. Finally, in an exothermic reaction, it says the energy required to break the bonds, which is at the start, the energy required to break the bonds. So you do have to transfer energy in. The statement says is greater than the energy released when the new bonds are formed. So if you have to put in more then you get out when you are forming your product. Overall, you're actually putting in energy during the process. So overall, net energy transfer inwards into the chemical system. Okay, so overall you would have a net energy transfer into the chemical system, and that would mean to say that everything would cool down in the surroundings because it's actually transferring energy in. So that's not what actually happens in an exothermic reaction. That's actually what happens in an endothermic reaction. So statement 3 is false. So the right response is 1 and 2 only. That is answer B. Now, in our cohort survey, we actually found that literally just over half of the year 11s tested succeeded in getting this answer. But we actually had 26.5% getting answer C. So answer C is 1 and 3 only. Statement 3 kind of looks correct. Perhaps they didn't actually realize that magnesium oxide and carbon were the products. So I can see why they went for that. And 14% actually went for D, which is a very similar response to the 8% that went for choice A. So perhaps there was just a little bit of guessing between those two. So it goes to show that this is actually a deeper concept. It does require a certain amount of work, but if you actually do succeed in getting the mark, you would actually be beating effectively around about maybe half of the cohort actually taking the exam. And that's always going to put you at an advantage, because then you actually get more marks than them and you rise higher up the ladder when it comes to getting the final grade. So it is something that is well in your interest to investing time when you're revising. So now we're going to look at question number 23, and you've got a chance to pause the screen if you wish to have a go at the question. Now, the responses that we had from the cohort was roughly around 20% of students would pick B, and 20% of students would pick C as the answer. However, neither of those is actually the right answer. So let's just have a look and see what is needed in order to complete this question. So what you have to start off with is a good idea of what the bonds are that are present in each of these sets of molecules. So we're going to keep it represented by the balanced equation over here. So there's two molecules on the right-hand side over here for the product side, and one methane. So that's that, and that's that. And we've got carbon dioxide over here, and we've got to draw two water molecules here. Now, at this stage, it would be very useful for you to get a hold of a calculator. Now, what you actually have to do for this question is you have to calculate first the total energy that's tied up inside the reactant. So let's just break this down. It's 410, 410, 410, and 410 from the table over here. These are not single O bonds, so I believe that is possibly how answer B and C could have been obtained. But these are these are the double bonds. So these are 496. So it's a double bond between the oxygens, and the double bond is not just two times that. That's a completely false misrepresentation of what the strength is of each of the bonds. The bonds are actually different in both bonds. So now we've actually got a chance to now look at the product. Again, we've got C double bond O. That's the important one. So you need to have 805 there, 805 there, and then you've got OH, which is this one over here, 460, 460, 460, 460. Okay, right. Now, there's another way in which people can go a little bit wrong. They may miss out on the coefficients that are written at the start of each of those. So they may use only one, for example, and not two. Right, okay, so we're going to put that in our calculators. What we're going to do is we're going to add these up. And the answer that we get is 2,632 for the combined energy in the reactors. We're now going to find out what the combined energy is within the products themselves. So add 805, 805, and 4 times 460 together, and you will get 3,450. Now, so you can use a mnemonic, calculate reactants and products, and then subtract. So the 2632 should go here. Take away the 3450, and that should give you, take away 3450, minus 100, minus 818, and that is in fact kilojoules per mole, which is answer A. So answer A is the correct answer. Right, okay, so let's move on to the next question. So pause the video if you need to have a bit of time to look through this one. Now, this is a question that is that does require remembering. So this is definitely a knowledge-based question. The diagram represents a lime kiln used to heat limestone, and it's to a very high temperature. And what you actually will get is you'll get the limestone. Here we go. Just want to get a little bit of a darker color here. Limestone is calcium carbonate. Here we go. Calcium carbonate. There we go. Nice big letters here, just representing calcium carbonate. You will actually get a thermal decomposition. It will be CaO, which is calcium oxide, plus CO2. So the CaCO3 decomposes to form calcium oxide, and that is this response over here. So the correct answer is C. Now, in our survey, Around about 75% of students were able to correctly identify C. However, the one with the biggest temptation was calcium carbonate, and I believe that calcium carbonate was chosen because people may have remembered calcium carbonate as being the chemical name for calcium carbonate. So perhaps a lack of knowledge there, and maybe they were trying to answer something in a way that was more familiar for them. So that was just basic knowledge. Right, I'm going to move on to the next question. 25, question 25. You've got a chance to have a look at that question. Pause the video if you want to have a go in it. So the way that you need to be able to do this question is all based upon the principles of what happens during displacement reactions. Okay, so with a displacement reaction, a more reactive metal, that's listed over here, will displace a less reactive metal from its compounds. Now, have a look at the metals. So let's look at magnesium first. Does it displace magnesium nitrate? No, of course not, because it's the same metal. Does it displace M? The answer is yes. So you would have to have magnesium here, and there's definitely M, which is underneath it somewhere. Okay, magnesium will displace copper, and it will also displace zinc. So we've got somewhere here at the bottom, and we've also got M. We've got magnesium right at the very top. So now we move on to zinc, and let's have a look. It's like zinc definitely is not strong. Is not high enough in the reactivity series to displace magnesium from its compound. It will displace M, and it will displace copper. So zinc is above copper, and it is above M. So now we can shift this around. Okay, dealt with that. Now M doesn't displace magnesium. We already know that. Does it displace copper? The answer is yes. So we've got enough information now to form a conclusion. You can leave the last ones, because you can actually check if you're right. So M should be M should be not unable to displace zinc. That is true. There's no reaction there. Copper should not be able to displace any of these metals, because there we go. Should not be able to displace any of those metals because copper is at the bottom of this reactivity series. So that's higher, and that's lower. So I think we've got our order here. Should be magnesium, zinc, M, and copper. And just give a quick check in the question itself. Make sure that you're not writing copper, M, zinc, magnesium, because that is in the reverse order. Perhaps people who would have picked that may have picked it because they thought it should start with the least reactive. So that's the answer to the question. Right, so let's have a look at our cohort. Now, unsurprisingly, 12% of students actually picked B as the answer. If they had just picked, if they had just actually picked the right answer, which was D, roughly around about 80% picked that answer. If they just actually worked their way through the question, just gave that last little check right at the very end, we would have found that over 10 to 12% of the cohort would have actually got the right answer as well. So we would have had maybe a hit rate of sub 90%. So there is going to be roughly 10% of people actually taking this exam who just get it wrong right at the very end. And what you've got to do is you've got to make sure that all of that work, all of that hard work that you put in is not then thrown away. It's not then thrown away. Here we go. Just want to make sure that we've got the quality there. Okay, right. So let's move on to question number 26. So this is a question on ionic equations. So if you want to pause the video, you may do so and have a go at the question yourself. Now, this is a question that is designed to throw the best candidates. You've got a lot of letters. You've got a lot of superscripts with the ionic charges. Try not to be put off by those. You've got to come up with some level of order of reactivity of the four metals. So let's start working with that over here. And let's try and see whether we can unpick some of these points. So Z is over here, and that's the metal. So if it's not an ion, that means it's the actual metal itself. So what's quite useful is that the question is friendly enough to have the ions in there. So the ions, the metal ions, will be in an actual compound. Okay. So all you need to do is just have a look. Now you can actually see the way that you must try and interpret this is that if a metal reacts successfully with an ion of the metal in the compound, then that is actually a displacement reaction. That would mean to say that the metal is above the ion that's inside the metal compound. So from this evidence, let's put Z above X. We don't know what else is going on, but we've done that one. Z is above W, so the question will then be, is W above X? Well, X is above W according to this third equation, so we can now change our order. And let's have a look at the fourth question, fourth piece of evidence. Y is above Z, so Y is right above here. So in the order, in the final order, we've got Y, we've got Z, we've got X, and finally we have W. So that is actually the final order from the most to the least reactive metal here. And now what we do is we just go to our table. So the best thing to do, really, honestly, the best thing to do is just don't look at the answers until right at the very end, and just trust in your procedure. Just keep your level head. There's a lot of information over here, but just think. I've done displacement reactions. Do I actually know about the ions being representative of the metal inside the metal salt solution? And that is pretty much the way forward. So do we have Y? Do we have Z? Do we have X? Do we have W? Yes. So the correct answer is categorically C. And roughly just over 60% of our cohort chose C. And very interestingly, the choices for A, B, and D were 10%, 12%, and 14%. And statistically, that would mean that A, B, and D is probably chosen by random by just under 40% of the students actually taking it. So if you want to get a mark and get a mark above 40% at least of the students that are actually taking this, then see that question through. It is a very rewarding question. Let's have a look at question number 27. Pause the video if you need to. So zinc is extracted from its ore, zinc blende, using two chemical reactions. The two chemical reactions are there. Zinc sulfide plus oxygen reacts to form zinc oxide plus sulfur dioxide. And then the second one is zinc oxide plus carbon reacts to form zinc plus carbon dioxide. Which substance is reduced? So you've got to try and make sure that we get these definitions correct. Question isn't asking about oxidized, but we can say that. I would start off with oxidized because oxidized is for this definition, it's a gain of oxygen, and reduction is the opposite. So it's a loss of oxygen. So the question then becomes, what's lost oxygen? Okay, now technically, what is actually lost oxygen? We should be looking at this side of the equations. So if we're looking at the left-hand side where the reactants are interacting with each other, you've got oxygen, which is there, and it is completely acceptable to say that oxygen started off joined on with another oxygen, but now the oxygen has lost the oxygen, and it's now gained something that was bonded to something which is no longer oxygen, which is absolutely fine. So what has actually been reduced in reaction number 1? Well, the answer is oxygen. So we got one of these two as being a possible answer. So we can cross out C and cross out D. That's between these two. Reaction 2 is much clearer. You're actually losing the oxygen from the zinc oxide. So the correct answer, sorry, A, you're going to have to be an answer for another day. The correct answer is B. Again, we actually have roughly around about 75% of our test cohort that actually scored the correct answer, and the others were 6%, 8%, and 12%. So I would say that if you knew it, you got the right answer, and if you didn't, you would just have no other choice but to pick another answer at random. Let's have a look at question number 28 now. So pause the video if you would like to have a go at it. Okay, so we've got magnesium nitrate, which has a formula as such. Got magnesium hydroxide. And we've got magnesium carbonate. Now, decomposition of magnesium carbonate is very, very tempting to actually say that magnesium carbonate will release carbon dioxide and oxygen. It's very tempting to actually say that that is the correct answer. But in actual fact, it is not the correct answer because magnesium carbonate decomposes thermally, so under high temperatures, to form magnesium oxide plus carbon dioxide. There's no oxygen that's actually released. Magnesium hydroxide decomposes to release hydrogen and oxygen is not the correct statement. It is actually water vapor. It's MgO plus H2O, and that is what happens when you thermally decompose that. Then you've got the other choice, which is wrong. Magnesium nitrate decomposes to release oxygen only. It's incorrect because there are actually a series of nitrous oxides that is released when you heat magnesium nitrate under hot, very high temperature conditions. Let's move on to question number 29. 29, which row describes the formation of single covalent bonds in methane? Pause the video if you need to, because you'd like to have a go at this yourself. So the formation of single covalent, well, there's the big clue. Covalent means that you have two atoms that share an electron pair. You've got methane, and if you want to just draw the outer shell of carbon, the electronic structure dot cross diagram should say dot cross diagram of methane is represented by that one. So atoms share a pair of electrons. Yes, definitely. So let's exclude C and D. C and D are incorrect because that's for ionic substances. So that is definitely a wrong answer. And so it's between these two. Both atoms gain a noble gas structure. Perhaps some people may not have realized that helium is a noble gas as well. So that is a true statement. They don't both have the same number of electrons in their outer shell. That's a big dose of generosity by the examiner there. That is completely wrong. It leads you straight to A being the correct answer. So if we have a look at our analysis, 70% actually got that question right. The most popular mistake that was made was to pick B. So we had roughly about 14% who actually get to a choice between A and B, and they don't actually see the job all the way through. And it's really important to make sure that if you feel as though the key is fitting inside the lock, that you keep going and you read through the question to make sure that you're not making a silly mistake. There'll always be a silly mistake point in the question, and try to avoid it. And our final question for the video is question number 30. Which substance is a macromolecule? So pause the video. And if you wish to do it. Okay, so simply speaking, ammonia, carbon dioxide, and water, all three are simple covalent. If we just, they're simple covalent molecules. So if we actually have a look at each of those, you've got NH3, CO2, and H2O. They all exist as separate ones. Whereas diamond is a structure that has carbons, and each of the carbons is basically a repeat unit of that. So each of the carbons is joined onto 4 more. So you just can pass away the time just drawing diamond structures to your heart's content. And that is the structure of diamond. If you just continue that, it's a massive or macro molecule. So the correct answer is C. Now, according to our cohort, we had 67% actually picking C. The most popular mistake was A, but just by a margin. A, B, and C were all 14, 15%, 8%, and 10% respectively. So those people who did not suggest that diamond was a macromolecule, looks as if those people would just guess. So around about a third, roughly a third of students taking the exam on the day will guess that one. Okay, and that takes us through to the end of part 3. Thank you very much for sticking by us, and hope that you enjoy part 4 as well, which is coming up very, very shortly. Take care.